Record. Yep. Okay.
Feel good?
Yeah, whenever you're ready.
All right. Good morning, everybody. Want to thank you all for coming out. We're the Keweenaw Survey Company. I'm Brendan Varga. I'm a civil engineering student.
I'm Spencer Plummer. I'm a surveying engineering student.
I'm Connor Mullen. I'm in geospatial engineering. I'm Hunter Hickman. I'm also in geospatial engineering.
And our project was the Huron Creek Survey. So here's a quick overview of what we'll be talking about in our presentation today. We'll go over some background information and the team's project scope. We'll talk about our preliminary site recon, the equipment and methods that we used on this project. We'll talk about setting control points and opus and how those things correlate. We'll discuss some field work in our cross-section survey. We'll talk about our cost estimate, our final products, some challenges we faced during the semester, and then we'll have some time for questions at the end if there are any. So for some background information, currently the survey data for the Huron Creek Watershed Management Plan is not up to date. As we know, there was severe flooding that took place here in 2018, the Father's Day flooding, and that washed out much of the land in the Houghton area, and the Huron Creek was no exception to that flooding. As you can see from the photo, much of the area was washed out and has drastically altered the formation of the creek. Because of this, LiDAR data was actually collected in 2020 by the NOAA in order to update the topo of the area that was affected. However, due to the limitations of standard LiDAR, it failed to measure the bathymetry of the creek. And so that kind of brings us into our team's project scope here. So Keweenaw Survey Company was tasked with updating the survey data for the Huron Creek Watershed Management Plan. What this entails, we were asked to complete a control survey in order to establish known points surrounding our site area. It's a little difficult to see from the photo, but the team's site area runs from behind the Walmart down to chutes and ladders where the creek actually feeds into the portage. So once we had those control points set, we could then survey cross sections all along the length of the creek in order to help supplement that existing LiDAR data from 2020. And we'll get into what's included in those cross sections a little bit later. We were also asked to locate and call out any culverts and bridges along the length of the creek. And once this data was collected, we would then process and analyze it so that anyone looking to make updates to the watershed management plan in the future has our information available to them. And so then the first step that the team took in completing this job was our preliminary site recon. And essentially what that is the team went out on foot with no equipment yet, just to observe the current conditions of the creek, see what we were working with. And the main idea was to determine what kind of equipment we were going to need in order to get the job done efficiently and safely as well due to the conditions that were out there. We also thought that it would be a good idea to photograph the current state of the creek as we walked along and put those photos into a geotagged album. So anyone that has any questions about any cross sections or what the area looks like at different places of the creek can open up this album in Google Earth and select the area in question and see what we saw out there at that time. And then so, for example, on the right there, if you were to select behind the Walmart, that would be the culvert you would see behind there. And then on the left here, we just have the team out doing some preliminary site recon work.
So the equipment that we used for this project is the Trimble R12i GNSS receiver. For our control points, we utilized one where we'd set it up on the control point that we set, and we'd let it sit there for about 2 hours so it could establish the point. For the cross sections that we did, we utilized two R12is. One was set up as a base station and the other was used as a rover. A little background into what that means is the base stations receive signals from GPS satellites and create a correction factor that eliminates errors in the GPS and then sends it to the rover. So we would set it up on the control point, kind of like we did for the when we set the control points, and then we take the other one around and we would hit all the important parts of the cross section. For setting our control points, we set 4 points, 2 at each end of the project area. We used magnetic nail, used magnetic nail and flagging to mark the locations. Flagging really didn't help that much because there was a lot of snow. And as I said in the previous slide, we did 2-hour sessions on each point, and this allows it to be extremely precise. And then once we got our control points set, we would take the data and we'd use the NOAA's online positioning user service, otherwise known as OPUS. That resource is available on the National Geodetic website. This provides access to high accuracy coordinates The coordinates are the average of 3 independent single baseline solutions. So what this does is it takes the baselines from already known points, and then it establishes what our point is. And then these are our control points that we received back from Opus for the rest of the project.
All right, so now I'm going to talk a little bit about the field work and actual conditions out there and the process of collecting our cross-section data. So to do that, we'll look at a few of those pictures that we previewed earlier on the map more in depth. This is the first one there is on the north side of 26. As you can see, pretty serious water flow coming through those culverts, and the conditions out there, you can tell from these pictures, were not necessarily ideal. There's a lot of ice and snow covering sections of the creek. We were out there a little over a month ago, actually collecting this data. You can see the R12I there. And basically our process for collecting data was we had one guy in waders down in the creek. And then the rest of the team was kind of helping along the edge to carry equipment and make sure everything was going well and staying safe. So for choosing our cross-section locations, there was a few things that we had to consider. For one, we wanted to keep them somewhat evenly spaced out along the creek. And that came out to about 300 feet gap between them over the length of the project. And spacing them out evenly just helped create a more accurate and complete model that can be used to better analyze the flow. And then there were in the project scope some specific locations at usually at bridges or major culverts where cross sections were requested. So we did our best to get those depending on the conditions that were out there. And then finally, and most importantly, accessibility to the creek and safety were really big determining factors in where we could do cross sections. Some sections of the creek basically were sheer like cliff faces on the side, so there was no opportunity to get in or out. So we would have to move that, not necessarily be at exactly 300-foot cross sections. And then obviously a lot of snow drift and ice buildup also made it kind of unsafe to step into the creek at certain areas. Don't want to risk falling through, so we had to make accommodations for that. And then here's a little overview of what exactly we're collecting at each cross section. So as you can see from this table, basically each cross section is comprised of 2 top of bank shots, one on each side of the creek, as well as 2 bottom of bank GPS shots, and then a center line shot, which is at the creek bottom, pretty much in the middle, just kind of eyeballed that. And then a shot for the water surface to also convey the water depth at that cross section location. These XYZ spot elevations are basically just farther away from the creek. If we were able to get in and out easily, we would collect these just to give a better idea of the surrounding topography of the area. And then inverts as well were collected at any culverts where we were able to easily access that data. So now we got just a few more pictures here. This is kind of from the same location as that first one on the north side of 26. And you can see pretty steep hill situation. I wound up kind of just sliding down in waders into the creek. As you can see, the rest of the team is kind of up top on the hill there, overseeing. And then here's kind of a instance where it was kind of a steep ravine, or it was like pretty much impossible to get in or out. So it was just a matter of trying to stay safe. Use the survey rod as kind of a third leg to poke around and make sure I wasn't gonna step somewhere too deep or too slippery, and just kind of safely make our way down the creek and collecting cross section as we go. Here's a short little video, kind of like a treacherous waterfall section. You can see there's a lot of like snow drift and things that really make it pretty unsafe to try to get in the creek there. So this is an example of an area where we just kind of had to move a little bit past it to somewhere that was more feasible to actually access.
So what you might be thinking about is, man, we did all this survey data, it took 3 months to do. How much would it cost for an actual survey crew to go out there? So we did a couple of estimates. We talked to one of the professors here at NTU, Joseph Foster. He was a co-advisor for our board, and we used that and also open source resources across the internet and various survey companies about prices, just different types of areas for the project. So we brought it down to 5 different categories, one being research, another being recon, so actually getting out there on the site, the comps and calcs, so any math that we got to do in the office work, and then of course the field work, and then the deliverables, which we'll talk about more in a second. So all these hours are very adjustable. You know, different survey teams will have different efficiencies. You'll have different rates and times. So this is just our estimate, but it's definitely something that can be changed given a bigger project, takes more time, or just more complicated work, or different accesses to software. So the total here takes into account any sort of office spaces, individual works, equipment maintenance, and then just unforeseeable problems that we can take that into account later. So some of the final products for the survey thing that we did is the raw point file, the CSV. This is the project file. This is to have the entire project into one format. And then the topographic map overlay is what you see here on the right, the different areas, the different evolutions. And then those X's are the actual cross-section points that we measured. And the LiDAR overlay, which we'll actually show in a second. And then as we spoke about earlier, the geotag photos that we could use on Google Earth or any other software that takes KMZ files of the Huron Creek. So you can look at that as well. So here you'll see a little LiDAR presentation of the creek. Those red little dots there are the actual cross sections that we took. And then the lines you'll see there are different things of elevation. This is what defines a topographic map. So just a little rendering of the Huron Creek. It was a little bit of a wider area and about like 2 miles, give or take-ish, from the start and to the outlet of the Huron or the portage. So just run through that. That's pretty cool. So then the biggest challenge that we have for this project is, you know, we're in Houghton, Michigan, and it's kind of chilly up here. For those that are not familiar with Houghton weather. So there's a lot of challenges that happen in this semester that couldn't have happened in the summer or in the spring, give or take when this project was going to commence. So there's a lot of snow, there's a lot of ice that we spoke about earlier, and just the challenges of going into the water, getting that information and getting those photos taken, all that survey cross-section data. And the biggest thing that we didn't perhaps spend a lot of time on was the equipment setup and the software issues. A lot of it came down to licensing between different types of softwares, how to pull the data from the specific equipment files, and then what do we do if equipment fails. So we are lucky enough that the project for the Huron Creek is local, so if we had any problems with equipment, we'd come back, reassess what we needed to do, and then go back out again. So it's just one of the challenges that luckily we didn't have to face too much with, but it's something to take into consideration for those that are going to do survey data in the future. So for a summary, we went over the background information and what our scope of project is, the recon that we did, the equipment and methods that we used for this cross-section survey, the control points, the actual survey itself and the points along with it, a cost estimate, and then what final products will be produced. I'd like to say thank you, and thank you for coming to our presentation. Do you guys have any questions? Fine, no.
I'll begin if that's all right, gentlemen. Good morning.
Morning.
You'd always, and before and during the discussions throughout the semester, what a factor the weather was and the conditions of the site simply because it was winter. Now, what would you have figured, let's say it was summer? Would it have been an advantage? Would that have changed your choice of equipment that you would use to do the survey work, the actual field work? I mean, clearly the office work, the post-processing of all your data, it's really has no bearing as what the weather is outside. But the thing is that how would you have seen that change with the decision of the type of equipment and perhaps how you would have approached the project?
I think our strategy would have been pretty much the same, like similar equipment tactics. I don't see why that would change, but we definitely would have gotten better data, more accurate data overall, just if the conditions were better, because we would have been able to do cross sections right where we wanted to, and it wouldn't have been as treacherous in certain locations where there's snow and ice blocking the creek and making it impossible to actually enter it. So that would have been the main thing that I would think is that it would just be more regular data, and we would actually be able to make sure that when we stick that rod in the ground, that it's actually on the ground and not on some piece of ice or like just somewhere in the snow, because we can't actually see it when there's, several feet of snow there that we're trying to survey through, so.
Yeah, it was definitely something to take into consideration with was just safety was our biggest thing. We didn't want to fall or anything into the ice and just cause potential injury. So like Connor said earlier, we had one-man waders going around. We had to give him all the equipment in a way that it was safe for him to get into the water, and then make sure that we're okay, that we don't fall in because we don't have waders. So the survey data that you see here is the most accurate that we could get at this point in time. If we did it in the summer, it would look a little bit different because, like Connor said, we're sticking holes in ground and we don't know if it's touching the ground or not, but it's stopped. So something solid there. And then the top of banks, the water lines, and of course, with in the summertime, you're going to have a different water surface elevation for those points as well. So you can take that into consideration. So you, like you said, you'll get a little bit more accurate points and a more accurate baseline model.
So I have a question on the topo kind of video you showed. It's, yeah, I don't know.
Jack?
There. So you just did the red points. Where did the rest of the data come from?
So the rest of that data is the LiDAR that we briefly touched on at the beginning. So basically this LiDAR was collected by a plane for like the entire surrounding region. And then they specifically want data for Huron Creek, but LiDAR in principle is shooting laser pulses, light, and measuring the returns. And when that hits water, it doesn't collect an accurate measurement. The light will just scatter, or it'll reflect in a different direction, not come back to the sensor. So they have, while they have this topography of the entire region in this LiDAR file, the actual creek is, it's not captured, and the creek bed itself is left out. It's kind of hard to tell here, but basically our points would be used to kind of fill in that gap and show what the topography underneath the water is.
Okay, so the red dots appear kind of like below the topographic lines
Right.
because the LiDAR isn't grabbing
Yep.
the actual land, it's grabbing water. Okay. Does the trees and stuff cause an impact with the LiDAR as well? The trees and vegetation and stuff, you said it doesn't go through water, so I just wasn't sure. Because that area has a lot of trees. So.
True. So the points that we have, those red X's that you see there, those are our points. But then we spoke about earlier that we had the LiDAR data from 2020. Luckily with that is we imported it with ArcGIS, which is a geodetic analytics software. So this is what is produced when you see a topographic map of Houghton and just close to the project. So with that data file, it was a point cloud data set, and it had different classifications in there. So if there is a sharp jump in elevation between point A and point 2 or point B, it'll actually cancel out all of those on top. And you can kind of see that in the video. If you look a little bit closer, all these squares right here, all these empty ones are buildings. So it's actually using those outliers and canceling those out so we can get this baseline area. So like, why is there no points here? It's because there's a building there, and the software we used took those out of consideration when considering this into a topographic area. So we decided just to do elevation, and you can put the entire data set in there, and of course it's going to look a little bit rough because the what it was flying over is collecting those LiDAR points, and of course it's collecting trees and all that vegetation stuff. We can 100% look at all that data, but it's a little bit fuzzy. So we as surveyors have to get rid of those outliers, and then that's what you see here with the holes in the ground, and then there's no trees like that. So luckily the software has different classifications of points.
Thank you.
On those same lines, Hunter, how difficult was it to dovetail the LiDAR data with your survey data or vice versa? I mean, did that also have a bearing on the coordinate system used?
Luckily, ArcGIS has a function where you can use state plane, local plane, like a global scene, that type of stuff. Once we changed the coordinates of the file, it matched up to what you see here and a little bit to what we saw earlier. So this right here is perfectly matched coordinates. So it was a little bit difficult for the use of the point cloud data because ArcGIS doesn't have a high res area of, or a high res area of Houghton. So when we put in the points of the point cloud, some points were under the map itself and some were way above it. Because just the points are a higher resolution than the map itself. So what we did was we took those points into consideration, and then what you see here is similar to what the problem was. But luckily, the use of the topographic map, there's not really use of elevation there for the X points because it's more of just a local state coordinate.
Oh, I have a generic one just because this is so outside of anything I've ever done. So for each of you, I'd like to know what class best prepared you for this project? Or classes?
I would say probably surveying field practice. That really came in handy for being in the field, doing all that kind of stuff.
Yeah, probably the same. The only true surveying class that I had personally was my intro to surveying, and there was a lab included with that, and that definitely helped be getting familiar with the equipment that we were using out there.
I would say geodetic positioning was a class I took where we got hands-on with the actual R12Is, like specifically. I know other classes I've been in the field doing survey stuff, but with that one, learning the actual specific software that we wound up using was really handy. Knowing how to start jobs and like import and export files. We didn't have to learn how to use it, so I would say that.
I actually have two. The intro to surveying, so we all know the basis of, I actually had a, like, what is a control survey, what is a control point, all that type of stuff. Shameless plug, SU 2000, Joseph Foster. And then also geospatial monitoring. I got a lot of practice with ArcGIS here, and it was very helpful of just getting the overall area and just able to use the point cloud software we were able to use, and then also produce the video that we talked about earlier.
You're already going to graduate, Hunter, so
Hey.
you're in the
It was a shameless plug there. Well, thank you.
I'm just appreciative, Joe, that you put up with me. 'Cause this is
What
so-
do you mean put up with you?